Good morning. Good morning, everyone. Are we live? Are you able to hear me? Good morning, everyone. Are you able to hear me? Am I audible? Just tell me in the chat section. Am I audible? Good morning. Good morning, everyone. Today we are going to study about reaction intermediates. Very important topic. Just wait a second. Yes. So good morning. All right. Let me start now. Let me start. Let me start this class. Today is very important topic. This would be your basics of entire organic chemistry. Right? If you are not able to understand these basics, your organic chemistry would be, you would be facing very difficulty in understanding organic chemistry. All right. So we need to understand this today's concept so that we can understand organic chemistry. All right. All right. So let us start. So I welcome you all to NEET UG English platform. Let's crack NEET UG on India's largest education platform, that is your Unacademy. I welcome you all here. All right. Let me introduce myself. My name is Nitesh Devnani and I have 5 years of teaching experience in chemistry. All right. And I have taught over 2000 plus students. I have taught over 2000 plus students who have got some great marks in NEET. All right. So let me tell you about the subscription plan. Let me tell you about the subscription plan of Unacademy. First of all, you need to download this app. Just download the Unacademy learning app. Download this Unacademy learning app so that you guys can access the subscription, as well as you guys can access the free classes here. All right. So see, when you will buy the subscription, you will have daily live class, you will have live test and quizzes, you will have structured courses, as well as there will be unlimited access. There will be unlimited access for whatever whenever you buy the subscription. Unlimited access means you guys can take classes that give tests according to your own comfort and on your own devices. All right. See, there are free live classes also, as I've told you. You just need to download the Unacademy learning app. Just download the Unacademy learning app. You will be able to access free classes also then. All right. So these are some of the educators on our platform. All right. So see, this is about the pricing. The pricing is of there are various type of pricing, but I would recommend you to go for either 12-month or 24-month pricing. So if you will go for, whenever you buy the subscription, just apply this code Nitesh YT. Nitesh YT. Whenever you will apply this code, you will get 10% off. 10% off. And 12-month course you will be getting at 27,000 rupees, and 24-month course you will be getting at 32,400 rupees after applying this code. You need to apply this code in order to access all these discounts. All right. So today's topic is very important. Today's topic is very important. All right. So we need to study this in very much in detail. Today's topic is reaction intermediates. Very, very important topic. All right. Very, very important topic. Great. Yes, 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 yes. Just wait. All right. All right. Let me start today's topic of reaction intermediates. First, let me give you some basic definition or basic understanding of reaction intermediate. See, you have your organic, molecule. Correct? On this organic molecule, your attacking reagents are attacking. All right, attacking reagents we have covered in our previous lecture. Those are basically your electrophiles, your nucleophiles. All right, so organic molecule is attacked by attacking reagents and they are converted into intermediates. All right, and then these intermediates are converted into either products or either byproducts. All right. Alright, so what are these intermediates? Today we are going to study about what are these intermediates. Alright, yes, hello Richu, hello. Today we are going to study about these intermediates. So what are reaction intermediates? Are you all ready for it? This is a very, very important topic. Reaction intermediates is a very, very important topic. So just give me a thumbs up. Give me a thumbs up or please write your name so that I should know who all are present in today's class, so that we can interact with all of you. Reaction intermediates. Alright, so these are those species which are formed during reaction. Hello Tharuni. Hello Pratyush. See, basically this is my number, so if you guys need if you guys want to have want to know details about the subscription plan, you guys can WhatsApp me here. All right, so let me give you reaction intermediates. Those species which are formed during reaction and are consumed before the completion of reaction. All right, see, these reaction intermediates are those species which are formed during this reaction and which are completed before which are consumed before the completion of reaction. These are reaction intermediates. All right, good morning everyone. So see, today we are going to study about reaction intermediates. Just pay attention here. See, there are basically three types. There are more reaction intermediates, but three are very much useful to us. Three reaction intermediates are carbocation, carbon anion and free radical. Alright, let me explain you one by one each and everything. Alright, first is carbocation. Let me break this. Carbo means carbon and cation means positive charge. So these are species in which carbon is having positive charge. Carbon is having positive charge. Those species are known as carbocation. Alright, let me give you example. CH3 plus, CH3, CH2 plus. Like if this is your ring and this carbon has positive, so see, in all these carbon is having positive charge, so these are what? Carbocation. All right, let me show you structure of this CH3 plus. Let me show you structure of this. Okay, tell me what is, how many subshells carbon has valence in its valence shell? How many subshells? Tell me in the chat section. Come on, everyone. Carbon has 2s and 2p. Correct. 2s means 1 orbital, 2p means 3 orbital. All right, this is good. So see, how many hydrogen are there? 3 hydrogen. So see, these 3 orbitals are used for bonding. 3 orbitals are used for bonding. All right, this orbital is what? Empty. This orbital is empty. Great Tharuni, great Rajni. Yes, this is empty orbital. So see, CH3 plus structure is C. Here it is H. H. Here it is H. This carbon is having positive charge, and this thing means it has empty orbital. I have told you all about this in our resonance class also. Alright, it has empty orbital. Got it? Is this much clear to all of you? This much clear to all of you? Tell me in the chat section if this is clear. If this is clear. Yes. Yes, great. Great. Now see. Second type of intermediate is carb anion. I'll explain you each and everything. Just attend this complete lecture. All right. Carb anion. Carbon. Today we are going to practice also a lot of question. Carbon anion means negative charge. So species in which carbon is having negative charge. Species in which carbon is having negative charge are known as carbanion. Correct? Let me give you example. Great Santosh, great Richu. No, you guys are on time only. Carbanion CH3 negative, CH3 CH2 negative. This is your ring, and if this carbon is having negative. Alright, these are what? Carbanion. Got it? Negative charge means this lone pair. It has lone pair. Negative charge means they have lone pair. Now see, again this carbon, it has 2s and 2p. It has 1 here and 3 orbitals here. Correct? So see, we are talking about CH3 negative. How many hydrogen atoms? 3. So here in this, these atoms are used for bonding. Correct? 3 orbitals are used for bonding. And your lone pair is present. This is your lone pair. See, is present in this orbital. This is containing your lone pair. Is this much clear to you? Is this much clear to all of you? Tell me in the chat section. Yes. It has 8 electrons. It has 8 electrons. Whereas carbocation has only 6 electrons. Why? Because only 3 bonds are formed. Here why 8 electrons? 3 bonds plus lone pair as well. Alright, so 8 electrons in carbanion. Great. Let me explain you about the third reaction intermediate. Free radical. Alright, these are species having odd or unpaired electron. Species having odd or unpaired electron are free radical. Alright. Alright. So see, examples are CH3 dot, CH3, CH2 dot. This dot means this is your odd electron. This dot means this is your dot electron. Your odd electron. Alright. Yes. Yes. I have an announcement for all of you after this class. I will just announce of something after this class. Alright. Just please wait about the timings. Yes. Now see, again if we say CH3 dot, so see, carbon has 2s and 2p, here 1 orbital, here 3 orbitals. Alright, so these 3 are used for bonding, and your this odd electron is present here. So if you see carefully, this is what? This is an unpaired electron. If the species are unpaired, they are known as paramagnetic. So free radicals are paramagnetic in nature. Okay. Yes. They have 7 electron. Perfect. Because 3 bonds are formed, so 6 electrons there and 1 electron in your odd species. 7 electrons. These are your free radicals. Alright. Now let me tell you this. See, this is your carbocation. This is having positive charge. So if it is having positive charge, tell me it is electron deficient or electron rich. Tell me in the chat section. If it is having positive charge, then tell me in the chat section whether it is electron rich or electron deficient. Tell me in the chat section. Yes, this is electron deficient because it is having what? Positive charge. Positive charge means there is no negative charge. There is less negative charge. Less negative charge means it is electron deficient. Electron deficient. Alright. Similarly, now see carbanion. Carbanion is having this excess of negative charge. So these are what? These are electron rich. These are electron rich. Alright. Are you getting my point? Great. Tharuni, Rajni, Piyush, Richu, Santosh. Great. Alright. Now see this free radical. See, do you know what is octet rule? Octet rule means there should be 8 electrons. Around an atom to be stable, there should be 8 electrons. But here there are only 7 electrons. It is less than 8. So it is less than 8. So this is also what? Electron deficient. This is also what? Electron deficient. Alright. Because it has less than 8 electrons. Got it? Hello solo guy, how are you? Alright, are you able to understand this? See, now in today's class we are going to study stability of intermediates. We are going to study about stability of intermediates. So see, 3 intermediates I have taught you. See, electron deficient and electron rich. Electron deficient are carbocation and free radical. Got it? These are what? Electron deficient. Electron rich is carb anion. Now look at it. See, whatever molecule there is, all the molecules want to be in a neutral state. See, here are electron deficient. the species are electron deficient. Alright, so those effects which will donate their electrons to these electron deficient species. Electron deficient means they have less electrons, means they need more electrons. Alright, they need more electrons. So those groups which would donate uh, electron donating groups, they will increase their stability. So tell me what are electron donating groups, which effect they do show. Electron donating groups, tell me in the chat section. Tell me in the chat section, which effect does the electron donating group shows? Plus R, plus H, or plus I, all plus 1 were electron donating groups. All plus 1 were electron donating groups. Alright, alright. Now see, these are electron rich, they have excess of electrons. They are saying that take away some R electrons. To make us stable, take away some electrons. So they are proportional to electron withdrawing groups. Now what are electron withdrawing groups? Minus R, minus H, minus I. Alright, is this much clear to all of you? You just need to remember this. See, it is carbocation. Positive, this means it is positive. Positive are stable by positive. Carb anion, it means negative. Negative are stable by negative. You just need to understand this. Positive are stable by positive, negative are stable by negative. Very good, very good, very good. Great. Is this much clear to you? Is this much clear to all of you? Give me a thumbs up in the chat section. Give me a thumbs up in the chat section if this is clear to all of you. Give me a thumbs up in the chat section if this is clear to all of you. Great, great. Now see. Stability order of carbocation. Stability order of carbocation. See, there are CH3, CH3, CH3 positive. There are these type of carbocation. Suppose there are these type of carbocation. Alright, so you need to find a stability order. Great, Solo Guy, Rajni, Richu, tell me the stability order of this. Tell me the stability order of this. What is the stability order? Great. Yes. Great. Why? Because this has 9 alpha hydrogen. This carbon is your alpha, this is alpha, this is alpha. 9 alpha hydrogen. Here it has 6 alpha hydrogen. Only this and this you need to count. You don't need to count this one. Here only this 3 alpha hydrogen, and here 0 alpha hydrogen. Alright. So this is what 3 degree carbocation. This is 3 degree carbocation. This is 2 degree. This is 1 degree. Alright. So what is the order? 3 degree greater than 2 degree greater than 1 degree. Fantastic. Great. So you need to remember this stability order, that 3 degree carbocation is most stable, then 2 degree, then 1 degree. We will make use of this in our further classes very much. Alright. Now see, stability of stability order of free radicals. Stability order of free radicals. Alright. Now suppose these free radicals are given to you. Free radicals means odd electron. So see, here it is odd electron. Tell me. Tell me the order of this. Tell me the order of this. Come on, everyone. What should be the order of this? Yes, Rajni, Solo Guy, Richu, what should be the order of this? Okay, okay. Now again, here also hyperconjugation. Here also hyperconjugation will take place. Alright? So yes, this is your alpha, this is your alpha, this is your alpha. So here 9 alpha hydrogen. Here this is your alpha, this is your alpha. You don't need to count this. Here 6 alpha hydrogen. Similarly here 3 alpha hydrogen and here 0 alpha hydrogen. So again this is your 3 degree, this is your 2 degree and this is your 1 degree. So more the number of alpha hydrogen, more is the stability. So your answer is 3 degree greater than 2 degree greater than 1 degree. Fantastic. Great, great. This is pretty much clear to all of you. Very good. Very good. Now let me give you stability order of carbanion. Stability order of carbanion. Alright. So see, again we are taking this example. Here it is 1. This one, this one, and remember, always remember, there is no hyperconjugation. There is no hyperconjugation in carbanion. There is no hyperconjugation in carbanion. There is no hyperconjugation in carbanion. Alright? You always need to remember this, that there is no hyperconjugation in carbanion. So what should be the stability order of this? What should be the stability order of this? Tell me. Tell me, everyone. I will explain you. See, all these are CH3 groups. Alright, these CH3 groups, when we were writing here free radical as well as when we were writing here carbocation, so we were explaining their stability on the basis of hyperconjugation. Alright, now in carbanion there is no hyperconjugation, but methyl groups show which effect? Plus I effect also. I have explained you plus I effect is also shown by these methyl groups. Now plus I would decrease the stability of carbanion. Why? Because as I have explained you before, that see, positive charge are stable by positive, but negative charge are stable by what? Negative. Alright, so here in this case, carbanion stability of carbanion is directly proportional to minus I, but it is inversely proportional to plus I, and this CH3 group is showing plus I effect. Yes, so here 3 plus I, here 2 plus I, here 1 plus I, and here 0 plus I. So plus I means inversely proportional. So what is the stability order? This is the stability order. So here 1 degree is more stable than 2 degree, then 3 degree. So stability of carbanion is explained by inductive effect. Why? Because there is no hyperconjugation in your carbanion. There is no hyperconjugation in carbanion. Alright, is this much clear to all of you? Is this much clear to all of you? Give me a thumbs up in the chat section. Give me a thumbs up in the chat section. Yes, now you guys are very much equipped with to perform all the questions. Alright, you are very much equipped. Just let me give you a couple of more points and then you will be doing a lot of questions in today's class. All right. So see, note. I've explained you this note also. Effect, sorry, order of effects. All right. The most prominent factor among all the effects is aromaticity. Then it is resonance. Then it is hyperconjugation. All right. Then it is inductive, and at last it is anti-aromatic. Why? Because anti-aromatic, we used to define them as very unstable. Very unstable. So aromatic is the most stable one, then resonance, hyperconjugation, inductive, and the anti-aromatic is the least stable one. Is this much clear to you? Is this point clear to all of you? Is this much clear to all of you? Tell me in the chat section. All right. Yes, great. Now, next point of this note is, or let me give you first some questions. Let us do some questions. Are you all ready for it? These are very good questions. All right. The question is, electromagnetic effect. I'll cover it, Rajni. That is not very much important. I will cover it in any class. All right. Okay. Question is, you need to compare stability. Compare stability. All right. You need to compare stability. All right. The first question is, all right. This is the question. You need to see. Now let me give you some brief summary. First of all, check whether there is aromaticity or not. If it is aromatic, it is the most stable one. Then see it is whether it is stabilized by resonance or not. Then hyperconjugation, then inductive, then anti-aromatic. You need to see this order. Every time you need to see this order. All right. This is your question. Tell me. Okay, let me do this one for you. Just check whether here it is resonance possible or not. Just tell me here whether it is resonance possible or not. Tell me in the chat section. Is resonance possible? Is resonance possible? Yes, resonance is possible. Double bond, single bond, empty orbital. So resonance is possible. Yes. All right. Just check here on this. Is resonance possible? Great, Harsha. Great. Just check in this one. Is resonance possible? In the B structure, suppose this is your A and this is your B. Is resonance possible? No, there is no resonance. All right. Okay. Next, see hyperconjugation. Just check for hyperconjugation. Is hyperconjugation possible? Hyperconjugation. For hyperconjugation, you check alpha hydrogen. So see, there are alpha hydrogen. The valency is filled by these alpha hydrogen only. So yes, hyperconjugation is possible. There are two alpha hydrogen. This is your alpha. Alright. So hyperconjugation is possible. Alright. Now tell me which effect is more dominant, resonance or hyperconjugation? Obviously resonance. So A is more stable than B. Are you able to understand this? Tell me in the chat section. Harsha, Rajni, Solo Guy, Richu. Tell me in the chat section if this much clear to you. Tell me in the chat section. Yes. Great. All clear? Let me give you one more example. Now let me give you one more example of this. Alright, you need to again find stability order. You need to find the stability order. All are these what? Carbocation. All these are carbocation. Alright, just to find the stability order. First check whether there is resonance or not, then see whether there is hyperconjugation or inductive. Just move in this direction. You will be very much clear with it. Come on. Yes. Just give me your order. This is your A, this is your B, this is your C. Now you have to do questions. All the questions are to be done by you only. Come on everyone. Which effect are you seeing? Which effect are you focusing on? Which effect are you focusing on? Yes, 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 yes. Hyperconjugation. Yes. See, there is no resonance in any of these. If there would have been resonance, we would have kept them as more stable, but there is no resonance. Alright, now see alpha. Alpha are directly which are attached to this carbocation. Here this is alpha, this is alpha, this is alpha. So here see there are 3 hydrogen, here there are 2 hydrogen, and here there are also 2 hydrogen. So 7 alpha hydrogen. Fantastic. Alright. Alpha here are this and this. So here 1, here 2, 3 alpha hydrogen. And here there is only this alpha. It has only 1 alpha hydrogen. So more the number of alpha hydrogen, more is the stability. A, B, C. Fantastic. Great. Great, 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 great. 1, 1. Harsha, this would have only 1 hydrogen, na? See, this would have only 1 hydrogen. Alright? Great. You guys are learning really great. Alright, let me give you some more example of it now. Let me give you more example of it. You need to identify these. Alright? Great, great, yes. This is your thing, and suppose you have your this. This is your A, B, C, D, and then your E. Come on. Yes, tell me in the chat section what should be your answer. Tell me in the chat section. Tell me in the chat section what should be your answer. Come on everyone. Yes everyone, tell me your answer. Okay, there are some answers. First of all, you will check resonance. First of all, you will check resonance. Is resonance possible in any of these? First of all, check resonance. See, in A, B, C, D, there is no resonance. But here in E, you have your resonance. What is the formula for this? Double bond? triple bond, sorry, single bond, and this has empty orbital. So resonance is the most stable one. So E would be most stable. E would be most stable. Yes. Then you check alpha hydrogen. So see, this is your alpha. This is your 3 alpha hydrogen. This is your alpha. This has 2 alpha hydrogen. This is your alpha. It has 1 alpha hydrogen. This is your alpha. It has 0 alpha hydrogen. Alright. So this should be your answer. This should be your answer. Alright. Yes, resonance is more influencing than your resonance is more influencing than hyperconjugation. Great. Yes. Yes. Fantastic. Is this clear to all of you now? Is this clear to all of you? One more question. Are you ready for one more question? Give me a thumbs up in the chat section. Also like this video also. Most stable alkene. Most stable alkene. You need to tell, or most no. Stability order. Stability order of alkene. You need to find the stability order. Alright? Yes, you need to find the stability order. Come on. CH2 double bond CH, CH2, CH3. This is your A. You need to find stability order. Alright. Let me see some more examples. And one more example could be this. These are your 4 examples. Come on. Let me see who all can do this. We are slowly and gradually increasing the level. We are slowly and gradually increasing the level. You need to check resonance also as well as your hyperconjugation also. Harsha, again do this. Wait. Let me see. Okay. Let me see. We'll check. Answer we'll check later onwards. Okay. Don't worry. Answer we will check. First check where resonance is possible. First check where resonance is possible. To check resonance, you need to check what are the types of system involved. What are the types of system involved? You need to first check that. You need to first check type of system involved. So now see. There here there is now let me do it. You answer me in the chat section whatever I'm asking with you. Let us focus on A option. Is resonance possible here? Is resonance possible here? No. What? Hyperconjugation? Yes. Hyperconjugation? Yes. This is your main thing and this is your alpha. So how many alpha hydrogen? 2 alpha hydrogen. Great. 2 alpha hydrogen. Correct? Now tell me, is this clear? Great. Now let us focus on B option. Is resonance possible here? Is resonance possible here? Please wait. Is resonance possible here? Tell me in the B portion, is resonance possible here? One second. Yes. Is resonance possible in B? Yes, there is resonance. There is resonance. Great. There is resonance. All right. Um, let us focus on C option. Let us focus on C option. Is resonance possible here? Is resonance possible here? Is resonance possible here? In C? In C, there is no resonance. In C, there is no resonance. But hyperconjugation? But hyperconjugation? Yes, hyperconjugation is possible. Here it is resonance. This is alpha. This is alpha. So 6 alpha hydrogen. Great. Great. 6 alpha hydrogen. Now tell me in the D option. Tell me in the D option. Tell me in the D option. Is resonance possible? Yes, resonance is possible. Double bond, single bond, double bond. Resonance is possible. Alright. But there is hyperconjugation also here. How? See, this is your main thing. This carbon is your alpha. This carbon is your alpha. So here 3 alpha hydrogen also. Yes. Are you able to understand this? Alright. Are you able to understand this? Tell me in the chat section. Hyperconjugation here is also possible because of 3 alpha hydrogen. Alright, so this has two effects, resonance and hyperconjugation. So this is more stable, D is more stable. Alright, then you have to see resonance, then B, then you have to see more alpha hydrogen, then C, and then your A. Alright, alright, are you able to understand this? Tell me in the chat section. Tell me in the chat section. Yes, very good. So it has two effect. You need to see both of them. You need to see both of them. All right. Now tell me in the chat section. Shall we move on to our next lecture? Shall we move on to our next lecture? All right. Shall we move on to our next lecture? All right. All right. All right. All right. Let us move on to our next lecture. Okay, now again you need to give me stability order. Again you need to give me stability order. Alright, this is the stability order. Alright, see, this is your CH2 plus, here it is CH3. Here again this benzene ring, this is CH2 plus and this is CH2 CH3. Again this would be your last question of today's class, and further class we will take next complete class. Next complete class is of your entire this thing only. We are practicing entire this thing in our next class complete. Alright, don't worry. Next whole class is your practice session. I'll bring lot of different variety questions and we will cover your complete GOC questions. Lot of questions. Alright, so this is your A, this is your B, this is your C, and this is your D. Come on. Come on everyone. Tell me. Yes. What should be the order? Again, you need to see hyperconjugation, alpha hydrogen. This is your alpha now. Now, this is your main thing. This is your main thing. And no, Rajni, you need to see alpha hydrogens. You need to see alpha hydrogen. This is your main thing. This is your alpha. So, how many alpha hydrogen? 3. Now, this is your alpha. How many alpha hydrogen? 2 alpha hydrogen. Alright. This is your alpha, which is directly attached here. How many alpha hydrogen? 1 alpha hydrogen. And this is your alpha. How many alpha hydrogen? 0 alpha hydrogen. So which is more stable? With more the number of alpha hydrogen. So A, B, C and D. Alright. Is this much clear to all of you? Is this much clear to all of you? Alright. So see, this was your last question of today, but next, let me tell you about the next organic class. Next organic class, or in the next organic class, we are going to have practice session of GOC. We are like right, we have just taken today a few examples only. In next class we'll take a lot of examples. Right now in this class we have taken only about carbocation. In the next classes I'll take about carbanion, free radicals, everything. Alright, so lot of questions we are going to solve. Now the announcement which I was telling about, daily now we will have our classes at 9 a.m. Daily we will have our classes at 9 a.m. Alright, physical and organic, one day physical and other day organic. Now why this shift of timing? Because see, there are various tutors on this channel. There are more tutors, so they have given a slot to each and every tutor. Alright, so that there is no clash. So now we have our classes at 9 a.m. early in the morning. I will also wake up early, you guys will also wake up early. So see, in order to achieve something, you need to sacrifice a bit. Alright, if you need 170 plus in chemistry, you need to wake up little bit early. Just wake up at around 8:30. Just wake up at around 8:30. We will have and come at 9 o'clock. Alright. Alright, yes Rajni, we will have daily classes at 9 a.m. only. Actually they have fixed this session, so this way you will have classes at 9 a.m. Don't worry, see we need to do certain bit of things. Alright, don't worry, we will take our classes at 9 a.m. regularly. Alright, is this clear to all of you? Is this much clear to all of you? Tell me in the chat section if this is clear. And in the next organic class, we will do a lot of practice of your entire organic chemistry GOC. Alright. Rajni, is it okay? Harsha, solo guy. Okay, Rajni, if we keep it at 9:30, that would be good. Rajni, tell me, if we keep it at 9:30, is that good? Harsha is also requesting for 9:30. See, I am here to take a feedback from you all. Alright, is 9:30 would be good? Rajni, tell me, Harsha and solo guy are okay with it. Is 9:30 good? Alright, let's keep it at then, not 9 o'clock. Okay, let's keep it at 9:30 a.m. Let's keep it at 9:30 a.m. Alright, I will talk to the management team and we'll keep it at 9:30 a.m. Don't worry about it. Great, Harsha. Rajni, 9:30 would be good. Alright, so you can sleep a bit at 9:30 also. Alright, yes, a little bit early is you need to wake up. Now please attend the next practice session of GOC. That would be very important. Alright, please attend the next GOC. That would be very, very important. All right. Okay. No, Rajni, I need you in morning classes also. I need to change your habit. All right. We will study at 9:30. Great. Okay. So we are ending this class. Next class is of physical class tomorrow. Tomorrow we will have physical chemistry class. Harsha, bye bye. Take care. I will see you tomorrow. Bye bye. Bye bye. Take care, everyone.